Hello everyone, today is February 6, 2022, and I just completed the binary search strategy for the intersection of two arrays. Now we check out the tab 2. So given two integer arrays, numbers 1 and numbers 2 return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So that means we don't handle duplicates, we just search one by one. That sounds simpler, simpler than the tab 1. So example here, that's the same. So we return 2. On this one, we return 4, 9. Okay. Constraints is same. It keeps same. So length from 1 to 1000, and element range from 0 to 1000. There's some follow up. So let me check out. What if the given array is already sorted? That's exactly what we are going to do. I'm going to do the binary search. Anyway, I have to sort it. Sorting the arrays, input arrays both. How would you optimize your algorithm? Before this chapter, I implement the solution with the hash map. Yes, hash table with the hash map tab. So next time, once that's sorted, I would do the binary search. Second one, what if numbers one size is smaller compared to numbers 2 size? Which algorithm is better? In that case, I would say in the previous problem, tab 1 implementation analysis, I described that. So for the bigger array, I'm going to do the search sorted. For things that is longer, so we do the binary search on the longer array. That will be the log base 2n, the numbers last 1, and times the length of numbers 1, the smaller one. That will be faster. So compared to the hash map, I think that's the same. No, that will be slower. Hash map will be slower than this one. If the number 2 is much bigger than numbers 1. 1 is bigger, 1 is small. Okay, what if elements of number 2 are stored on disk, and the memory is limited such that you cannot load all the elements into the memory at once? That means limited space of memory, so we do need the frequency loading. It really depends on how big and how limited the memory is. I would say if the memory is big enough for the smaller array size to load it, I would do the binary search to store all the sorted array, smaller array to the memory, so we don't need a frequently disk read and write. And otherwise, if that's even smaller than the smaller array, that would be trick. I'm thinking maybe we could do still with the smaller one. Yeah, whatever. That will be binary search is still the good option. Okay, so since we just implement the tab 1, so I'm going to do coding first directly. So that will be the intersection and 2 right here. Since we do the quick sort, so I need a basic compiler function. So constant void void pointer a and a constant void pointer b, and return pointer convert to integer voiter and minus pointer container and refer to b. That's more clear. Okay. And binary search, yes, so that will be return bool, so binary search, so numbers, and a size is length, target. Okay, basically I need to declare the start and as my user to be made. Here we go. And the binary search initialization start is made equal middle equals 0 and end equals the last minus 1. Okay, so a while start lies equal and we just start a loop. We start a loop, so we will do if numbers made greater than target. We need searching backward. Okay, backward. That means and equals made minus 1. Else, if numbers made greater less than target, so we needed searching the forward to the right side. So the start equals made plus 1. Else, that means we found the target, just return 2. Okay, else means else return false. Oh, I need to declare calculate made at here start plus and minus start divide by 2. Okay, same things. I do declare the return equals none, and the searching base one for the pointer to the longer array, and the target side that will be for the shorter array. So I also need for the for loop index to 0 and the target minus 1 for the initialize. Okay, so on the very beginning I could do quick sort numbers 1 oh, I also need to do the length, so okay, target length and search length. Okay, we do if numbers 1 size greater than the numbers 2, we just make sure the search target search base equals the longer one. numbers 1. Okay, the target site equals the numbers 2. Okay, the search length equals numbers 1 size, and the target size target length equals numbers 2 size. Else there will be 6 lines copy to here, and we swap to all the number 1 to 2 and the number 2 to 1. Okay, and then we sort it. So numbers 1 and the size of integer and compile. We copy that and swap all the 1 to 2. Okay, for loop I equals 0 and I less than target length I plus plus. If the target equals target site I, then continue. Else target equals no, we don't. Okay, hold on. So in that case, we don't handle the target. We don't handle the duplicate, so we don't need a target right here. So that's okay. So basically that will do if binary search. Okay, search base and the search length, and target is target excuse me, site numbers I. Once that is true, we just return. Hold on, we didn't declare that one, so we just return declare malloc, the parsing malloc. Okay, that will be the target length and size of integer. Okay, so index equals target site I. Okay, else we don't do anything. So and later on we just return index, that's it, and return as the final recall. Okay, I think that's all. Let's check the logic here, the compile, the binary search, and the intersection. So we just check which one is the bigger one. We take the target element from the smaller array and searching on the longer one. Since the binary search will efficiently decrease the searching steps in the longer one. So, and quick sort. That one, and that one, that looks good. Okay, I think that's all. Let me try to run it on the Leetcode and check the result. Okay, run the code. Calloc. Okay, so I used the wrong function here. I try to initialize the return array, so okay, and oh dear, I made another exact same stupid mistake. Okay, that returns 0 0, not right. Oh, that's the wrong one. That's not equal, not compiled. That's the revalue. Okay, here we go. I do the Summate. Wrong answer. How that happen? So that's expect 1 and I output 1 1. Oh, okay. That's the logic I didn't handle. Oh, I see. Let me think. Okay, that's the case. I didn't handle it. So I need a logic to count. Okay, so basically we could do this. Okay, so we could do this in a binary search. Okay, I think I could do the quick implementation. So since the value, the element value from 0 to 1000, so I could do once they found 1, I just change the value to different. So numbers made equals maybe just -1. Yes, -1, so that won't happen. Okay, let me check. Okay, I got the correct answer. Let me submit again. Let's see. How that happen? So output expect 1 1, but we fix the first one, we just return true. How that happen? Let me think. Okay. Let me add a debug function to print out. So print array numbers anti-lines. That's it. Okay, for int equals 0 and I less than lines I plus plus print, I prefer print array in address and print search base and search length. Okay, this is right answer. We don't need checklist. I'm going to change the custom test case and check this one again and run the code. The binary search didn't search in the first one. That's the case. Let me think of the binary search. Let me print out something. Start and made and start and made. Okay, run that again. Okay, I'm searching 11030 and oh, okay, not right. Okay, not good. Okay, that's why. That's because I think I got the problem because once I reset value to the 1, either I need a run the quick sort again. Oh. Okay. We could do this. Binary search and base and search. We don't do this. We just do after 1. Okay, we do here. We do only we found 1. So if else we don't have to run the quick sort again. Let me check. Yes, that's the case. Yeah, we found 1. Let me check anything else. So so I submit. That's accepted. Let me see what's the. Okay, my code is too slow. Let me try write it again. That's because the run quick sort are too much. Let me think anything else. So exact. Yeah, I'm thinking a different way to save the additional quick sort here. Maybe we could do this. Okay, we need an index. Let me think. Okay, we have index here. That will be fine. So we could search at index. Okay. Okay, that will be one. And here we don't need. No. We need a move. Okay, that's move. Memory copy still take time. Headache. Let's try memory copy here. I'm thinking searching less smaller less of the array to make sure we got the right one. We avoid the sorting again. But in that case, if I swap between the mid and the end, but we need memory copy here. Okay, so instead I will set a value here. I don't do that. I do memory copy. Okay, memory copy from start, target, source, and target. Okay, that will be the numbers made plus 1 and size of integer times lines minus made minus 1. Let me check. So just end. Nice minus 1. Nice. Okay, that's still indexed. Should be life minus made minus 2. Okay, that makes sense. Okay, that's the length and that's the one. So we just remove the one and yes, we don't need this one. We just remove the length and remove the made one, the equals target. We just memory copy all the right elements of the target to move one step ahead, one element ahead. And in that case, I just searching the less and less index. Once we found it, and let me open the print array and try run it again. That looks good. And Summate. Negative size. negative size parameter. Okay. Okay. Let me do this. Let me do the add a restriction here. If made plus 1 less than and. We do memory copy, otherwise we don't do this. Okay, we got the right answer. Wrong answer. So expect 1, 2, and I only output 1 because first one I search 1, that's fine. Next time I searching, hold on, 1, 2, I got 1, so I need to move 2, right? Zero, 1, 0. And after that 0, 1, 0. Okay, 0, 1, 0. Let me copy the output and check the logic of the code. I will paste the different windows of the gedit. Okay. Okay, back to the code. For the 1, 2, the array, and beginning start 0 and 1 and made it 0. And we searching 1, so 0, that's already 1, that's equals 1, so but 1, 0 plus 1 is 1, 1 not equal, okay, we didn't do made plus 1 less, and then equal, we do this, let me check. I know that's because that is too short, didn't do the swap. That's still wrong. Your answer is 1. Hold on. Made plus 1 less and equal and. No, we do here. We do less. I got same thing. 0, 1, 0. Okay, 0, 1, 0. 0, 1, 0. So we know number 0, 1 is 1. Target is 1. So that's equal. We go this branch. 0, 1 less than 2. Yeah, that's right? 1, 0. That's do the memory copy. How that happen? So So I will copy the 0 to the 1, and the length, let me see, length is 2 minus 0 minus 2, that's 2. Oh, hold on. How that happen? I do calculation wrong, so let me see. Okay, that's the right one, and then let me summate again. 0, 1, that's 1 less. Okay, I didn't. 2, that's 1, that's 1, that's fine, right? How that happen? Memory copy overlap. Okay, that means the size is overlap. 0, 1, 2. Let me copy that. We do here, so 0 for the first step, that's searching the 9, so 0, 4, 0, that's fine, and 0, 0, 1, 2. How that happen? How that happen? Why that search left? The target search first. Okay, that's 4. Yes, first target. Okay, okay, we're searching the third base area is 9, is this one, 44899, and searching the first element is 4, so that will be 0, 4, 0, that's fine, and without search 0, 0, 1, 2. Okay, in that case, hold on, 0, 2 is 8, it not match. We need to go one loop. How that end? Okay, that's memory copy. That means that equal. How that equal? Oh, okay, that's wrong place to place that one. So let me change the test case to this new one. Run the code. Okay, that's okay. Next round is 0, 1, 0, 1, 0. So that first one is 0, so that match the target 4. Okay, match the target 4. Same things, I have to copy that one. Back to the logic right here. So the made is 0, 0 plus 1 is 1. Last is 5, that will be fine. So let's go to memory copy. 0 to start, from start plus 1, and set is 5 minus 0 minus 1 is 4. That's 4, that's right. That's right. Overlap. Overlap memory range. It seems. Let me check. Let me print this out here. 0. I'm checking again the memory copy function. Let me see if I'm wrong. Memory copy. So the memory copy, the first one will be the destination source and size. That looks exactly right. So why? I don't understand why that here is wrong, but let me add the item operation to check. Made 0, 0, 1, last is 4, that's fine. So that will be the 5 for 5 array. Let me see. So that's 5 array, and the copy destination source is made plus 1. That's 4. Size integer. That's fine. Why that happened? Okay, let me print more here to get some, to see if we have some hint. Numbers. One, 10, 14. 10, 14, how that happen? 10 to 14. Zero, 1, 2, 3, 4. Size of integer and size of integer equals okay, length is 4, that's fine. Size is integer. So the length is 4, size of integer is 4. Oh no. The last atom of this array is 4 times 4 is 16, and that will be 10 to 16. That's 20. That's no problem. Memory parameter overlap memory range. Just copy just the 16. I don't understand how that happened. I can't find out why that's memory overlaid the range. My understanding is supposed inside the range. Okay, made plus 1. That's 1. That's so we could start 1, 2, 3, 4. So that's 4. That's right. Why? Still got this, and even I minus 2, that's still overlay. So something wrong here. Memory copy 4, 4. Why? Why? So 44899. So once we search 4, we need to move 4 to here. But why I cannot do memory copy here? Okay. Okay, so I have a pause for this exercise, and I check the memory copy parameter overlay. That means source and destination has been overlaid, so it's restricted. So I'm thinking if I could use memory copy for that. So let me try memory copy here. So memory copy, memory move. So the destination source, they are same, right? Let me check. Okay, here we go. So I just learned this fact. So memory copy has the memory parameter overlay restrict. Memory move doesn't have it. So let me command out all these things and try to summate again. Okay, summate. Wrong answer. So 1, 2, 1, 2, 1, 2. So that's the 1, 2. We search 1, and we search 1. We got the 1, and we try to move to the second. We need to open this one again. Now this one. Open the debug output again, and let me copy the example here. Run the code. Zero, so last will 0. That means cannot do this. Okay, before that will made 0 length 0, so made a 0 length equals 2, so made a 0 length equals 2, so in that case we need to move at least one step. It seems the moving length size is changing all the way. Let me check. So I got round third when I do the remove size 1. Okay, time overlapped. Okay, time exceeded the limit, so that means print not good here. No print. Let's do Summate again. Okay, finally I got accepted result. Let me check. It's only 26%. Let me do Summate again and check if the result performance keep constant. So 49. It's okay for the current result. It's around bit 50. So far I don't know what's the better performance for the binary search strategy. Let me summarize what I changed. Let me check. So binary search, that's fine, and so that big change is the logic part. So due to the requirement for to list all the appearance as many times as it shows, so I have to record a way to mark if that element has been compiled and find out. So in that way, once I found the target, I just move the target right to the target position. That's why the move from the mate to mate, from the mate plus 1 to the mate. And in the binary search, I just do the search length minus index. That means how many elements I found it. Let me check. So all these things, I think that's new. And the intersection, it looks good. I remember I do some syntax fix. That's minor things. Target. Yeah, that's pretty much. Yeah, I think that's all for today. Finally, I got beat 50% performance for the C code. Yeah, pretty much. Thank you for watching.